Let's now differentiate this function using logarithmic differentiation. In step 1, we are going to replace fx by y. And we get that. Now we are going to apply logarithm. We can simplify a lot now. First of all, we will use the power rule for logarithm and we get 5 times ln of this expression. Now we can break this to a sum and a difference. The 2x e to the x is in the numerator, so we're going to have ln of 2x plus ln of e to the x, which is just x. And then we have to subtract ln of tangent x because tangent x is in the denominator of that. Now we just have to differentiate each part. So here is the implicit differentiation. As usual, when we differentiate ln of y implicitly, we get y prime over y. On the other hand, we are just following the rules of differentiating ln of a function, and also here we have to differentiate x, which is just 1. Now we have to multiply everything by y because we like to find y prime. But we don't want to have y in the answer. So we're going to replace y by fx. And we get that. In all the examples, we could differentiate a given function using the chain, product, quotient rules. We choose to use logarithmic differentiation because it was simpler. But let's say that we want to differentiate fx equals x to the power of x to the power of 2. Pay attention, this function is neither a polynomial nor an exponential function. We can apply neither the power rule nor the derivative for the exponential function. Logarithmic differentiation is not optional, it is a must. As a rule, a function of the form fx equals a function gx to the power of another function hx can be only differentiated by logarithmic differentiation. So let's differentiate that. First, we are going to replace fx by y. Now we are going to apply logarithm. And here's the whole idea. Instead of getting this terrible function, look what we have here. We get that ln of y equals x to the power of 2 times ln of x. It means that we can differentiate this very easily. So on one hand, we get y prime over y, and on the other side, it's just a simple product rule. We can simplify that, and also we can multiply both sides by y to get that. Now we're going to get rid of the y by replacing that by x to the power of x to the power of 2. And here is the derivative of this function. Let's take another such example. fx equals sine x to the power of sine x. Again, we must use logarithmic differentiation. First, we will write y equals sine x to the power of sine x. Now we're going to apply logarithm both sides, and we get that. We're going to simplify this and look what we get. ln of y equals sine of x times ln of sine x. And as usual, on the left side we are going just to apply the product rule. Don't forget that the derivative of ln of sine x is cosine x over sine x. As you can see, I can cancel that out, and I get that. Now I multiply everything by y, and now I'm going to replace y by the function f(x), and I get this. Another example. Differentiate f of x equals sine of x to the power of e to the x. We must use logarithmic differentiation. In step 1, we will get rid of fx and have y instead. Now we're going to apply logarithm. We are going to apply rule of logarithm to simplify that. Now we're going to differentiate. And again, on the right side, we have to use the product rule. You can simplify a little bit. This is cotangent of x. We're going now to multiply everything by y. And now we're going to replace y by fx. We will finish this section by finding the second derivative of x to the power of 3x. I would like to recall that the second derivative is the first derivative of the first derivative. So first we have to find the dx of x to the power of 3x. This is of the form a function to the power of another function, so we must use logarithmic differentiation. We apply logarithm and we differentiate. Okay, we can do that, cancel the x. And now we will multiply everything by y. We will replace y by the function, and we have the first derivative of x to the power of 3x. Now we need to differentiate again the first derivative to get the second derivative. Again, because we have x to the power of 3x here, we have to use logarithmic differentiation again. So let's apply logarithm. We get that. I also simplified already that ln of a product is the sum of the ln's. Now I simplify more. ln of x to the power of 3x is 3x times ln of x. And now I'm differentiating. Pay attention. What is the derivative of ln of y prime? You do a fraction line. Under the fraction line, you have the function y prime. Above the fraction line, you have the derivative of y prime, which is the second derivative of y, or y double prime. On the right side of this equation, you just apply regular derivative. And you already know how to differentiate ln of a function. And then for the part of the 3x times ln of x, we have to apply the product rule. You can do that. And we can also cancel this 3 here. Now we have to find y double prime. To get y double prime, I have to multiply everything by y prime. So I do that, and don't forget y prime is 3 ln of x plus 3 times x to the power of 3x.